folks, what we're going to do in this video is I'm going to present you some exercises in divisibility. Remember, we have 3 videos for divisibility. I hope you've watched all of those. This is still under our course or playlist in Fundamentals of Mathematics. So what is given here in our video is that we're going to make or check if whether these numbers are divisible by any of these rules that we have talked about. Remember, we have talked about the divisibility rules in 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 13, and 17. So this is one video, this is also another video, and this is also one video. So I have 3 separate videos for them. So let's try to use those rules, okay, in determining if this are divisible by this. So what we're going to do in this exercise is for each number on the left here, the first column, put a check under the numbers it is divisible by. So for example, here, so for the number 432, is it divisible by 2? So remember the rule in divisibility by 2, if the last number is even, that's the ones digit. If it is even, it is divisible by 2. So therefore, since 332 is an even number, since it ends with 2, so therefore we can say that it is indeed divisible by 2. So let's put a check there. Let's use red. Why not? Okay. Now, for divisibility of 3, remember, if the sum of the digits are divisible by 3, so therefore it is. So let's try. 4 plus 3 plus 2. What's that? 4 plus 3, 7 plus 2 is 9. So the question is 9 divisible by 3? So yes, it is. So therefore, 432 is divisible by 3. Let's put a check there. For number 4, there's a lot of rules there. We can use one of them. So first is if the last 2 digits is divisible by 4. So is 32 divisible by 4? Well, yes, it is. Let's put a check there. Or if you want, we can check the third rule. If the tens digit is odd, and we know 3 is odd, and the ones digit must be 2 or 6. So since this is 2, so therefore this is divisible by 4. Okay. For number 5, is the last digit or the ones digit ending with 5 or 0? No, it's not. So therefore, it is not divisible by 5. So we'll not put a check mark here. For 6, it will be divisible by 6 if it is divisible by both 2 and 3. So since 2 is checked and 3 is checked, so it will be divisible by 6. For 7, what we're going to do here is that if a difference between twice the last digit and the other digits is divisible by 7. So what will this be? So the difference between twice the last digit, so this is the last digit here, twice that is 4, and the other digit is divisible by 7. So if we're going to subtract 43 by 4, so this will give us 39. So is this 39 divisible by 7? So clearly it is not. So therefore, this 432 is not divisible by 7. Okay. Now, how about to check if 432 is divisible by 8? So how do we know if it is divisible by 8? If the number represented by the last 3 digits, that is the ones, the tens, and the hundreds, these last 3 digits actually must be divisible by 8. So how can we check that? I think there's no clearer or better way to check that by dividing it by 8 itself. So 432 divided by 8. So 43 by 8 is 5. That's going to give us 40. Sorry. Okay, 40, that is going to give us 32. 32 is 4, so therefore there's no remainder because this is going to be 32 minus 32, which is going to leave us 0. So therefore, since there's no remainder, we can say that this 432 is indeed divisible by 8. So let me write it there. How about 9? So for the 9, remember, if the sum of the digits is divisible by 9, it will be divisible by 9. So let's try 4 plus 3 plus 2. Again, 4 plus 3 is 7, plus 2 is 9. So indeed, 9 is divisible by 9. So therefore, it is a check here. It's a check here. Is it divisible by 10? So does it end with 0? Well, clearly it's not. So it's not divisible by 10. 11, what we're going to do is to do the process. So 4 minus 3 plus 2. What we did is just we're putting alternate signs with the digits starting with plus 4 minus 3 plus 2, and then if it will end up with 0 or a multiple of 11, it will be a multiple of 11. So 4 minus 3 is 1, 1 plus 2 is 3. 3 is not a multiple or a multiple of 11 or 0, so therefore it is not a multiple of 11. For 13, um, if the difference between 9 times the last digit, that's the ones digit, and the other digits is divisible by 13. So let's try. 9 times 2 is 18 minus 43. This will give us what? 43 minus 18. So let's put it in in the horizontal mode. Okay, so this will give us 3 bar 5, which is eventually 25. Okay, so that's 25. 25 is clearly not a multiple of 13, so this 432 is not a multiple of 13. And how about 17? So similar with 13, only that we're going to multiply the last digit by 5, not by 9. Okay, so 2 times 5 is 10. Okay, 10. Subtract that from 43. That will give us 33. So therefore, 33 is not a multiple of 17. So yeah, this 432 is not a multiple of 17. And yeah, that's it. That's our number or our answer in number 1. That's 432. It's divisible by 2, by 3, by 4, by 6, by 8, and by 9, as far as our rules are concerned. So we end with 17. Okay, now let's move on to the second number. We have 2,390. So is it divisible by 2? Yes, it is. It ends with an even number. Is it divisible by 3? So let's check. 2 plus 3 plus 9. So what we have here is 2 plus 3 is 5 plus 5 plus 9 is 14. So that's clearly not divisible by 3. How about 4? Is 90 divisible by 4? Okay, is 90 divisible by 4? Let's try if you want. We can divide that manually. We have 2 here, that's 8, and then we end up with 10, and then we have 2. 2 times 4 is 8. We have a remainder of 2. So therefore, since we have a remainder, it's not really divisible by 4 itself, since it's not a whole integer. So therefore, it's not divisible by 4 clearly. Is it divisible by 5? Yes, it ends with a 0, so it should be divisible by 5. Is it divisible by 6? It's not divisible by 3, not completing the rules that it should be divisible by both 2 and 3. So since it's only divisible by 2, not by 3, it's not divisible by 6. Is it divisible by 7? Okay, let's check. If the difference between twice the last digit, this is 0, minus the other from minus from the other digits is divisible by 7. So let's try. Twice 0 is 0. We have 239 which is left. Actually, we can continue the process. Okay, twice 9 is 18. Deduct that from 23. What we will have is 5. Now, 5 is clearly not a multiple of 7, since actually it's not a multiple of the table of 7 at all. So therefore, 2,390 is not a multiple of 7. Is it a multiple of 8? So what we're going to do is just check the last 3 digits. So we have 390 divided by 8. So we have here what? 3. 3 times 8 is 24. Or let's put it 4 rather. 4. 4 times 8 is 32. So what we have here is 7. Um, 7 is 9, 8 rather. 8 times 8 is 64. So what we have is we have a remainder of 6. So therefore, no, it's not a multiple. It's not 6. It's not a multiple of 8 since there's a remainder. So therefore, 2,390 is a multiple. It's not a multiple of 8. Is it a multiple of 9? So let's try to add again. So we have 2 plus 3 plus 9. It's 14. It's not a multiple of 9. So let's not check that. Is it a multiple of 10? So yes, it is, since it ends with 0. So is it a multiple of 11? Let's try. 2 minus 3 plus 9 minus 0. We can, if you want, let's put that. Okay. 2 minus 3 is minus 1. Plus 9 is positive 8. So yeah, that's not a multiple of 11. So let's not write it there. Is it a multiple of 13? So what we're going to do is 9 times 0 is 0. 239 is the one left. And then notice that 9 times 9 is 81. Subtract that from 23. It's going to give us a negative number. So therefore, this is not divisible by 13. Not divisible by 13. How about 17? So what we do with 17 is just multiply this number, the last digit, by 5, and then subtract it from the other digits. So again, just like in the 13, we have 239 which is left. We can continue the process. 9 times 5 is 45. Subtract that from 23, that's a negative number, so therefore it's not a multiple of 17. Okay, so we have three numbers which is divisible. Okay, 2,390, so it is divisible by 2. It is also divisible by 5. It's also divisible by 10. Moving on for number 3, so we have 3,968. Is it divisible by 2? Clearly yes, it's 8. Is it divisible by 3? So maybe it's okay to add them. Plus 9 plus 6 plus 8. What we have is 3 plus 9 is 12. 12 plus 6 is 18. 18 plus 8 is 26. So 26 is clearly not a multiple of 3, so therefore it's not divisible by 3. Is it divisible by 4? So let's go into check. We're only going to check the last two digits here. Okay, and then 68 divided by 4. So we have 1, 4 here. We have 2, 8. That's going to be 7. Okay, or so therefore 7 times 4 is 28 also, leaving us a 0 remainder. So therefore it is indeed divisible by 4. Or we can checking if the tens digit is even, so that's 6, it's an even number, and the ones digit must be 0, 4, or 8. So since it's 8, so therefore yeah, it's divisible by 4. Okay, so 3,968 is divisible by 4. Is it divisible by 5? Clearly not, since it ends with 6. With 8 rather. It's not divisible likewise by 6 because it is not divisible by 3. Is it divisible by 7? So let's check. Twice the first digit, 8. 8 times 2 is 16. Subtract that from the other digits, 9, 6, 396. So if we do that, that will give us 308, 0. Continue the process. Twice this 0 is just 0. This will eventually lead us with 38. Is 38 divisible by 7? Well, clearly not, because the nearest one is 35, which is 7 times 5. So therefore, 3,968 is not divisible by 7. Is it divisible by 8 though? Let's try to check 968, that three-digit numbers. 3968, is it divisible by 8? So this is 1, we have 8 here. Carry down the 1, and then we have 6. This is 2, this is 0, this is 1. Remainder 0. So since there is no remainder, so yeah, we can say that 3,968 is divisible by 8. Yeah, that's it. Is it divisible by 9? Let's check if it is divisible by 9. 3 plus 9 is 12. 12 plus 6 is 18. 18 plus 8 is 26. No, it's not. Okay. Does it end with 0? No, so it's not divisible by 10. Let's try for the divisibility of 11. 3 minus 9 plus 6 minus 8. So is it divisible by 11? Let's try and check. So we have 3 minus 9 is minus 6. Minus 6 plus 6 is 0. The remaining one is the answer, minus 8. So therefore, this is not a multiple of 11 nor 0. So therefore, it's not divisible by 11. Let's try if it is divisible by 13 though. So 9 times the first digit. 9 times 8 is 72. Subtract that from the remaining numbers, 396. So if we do that, what we have is 324. We can continue the process to give us okay, let's move forward. So we have 324. So 4 times 9 is going to give us 36. Okay, and then we're going to minus it with from the remaining digits. So we have 32. So obviously we're going to end up with a negative number, negative 4. So therefore 3,968 is not divisible by 13. Lastly, let's try if it is divisible by 17. So what we're going to do is do the similar thing with the 13, only by 5. 4 times 5 is 40. Minus that from 396. So what we have is 356. Continue the process. 6 times 5 is 30. 30, deduct that from 35. That's going to give us 5. And 5 is not multiple of 17. So clearly 3,968 is not divisible by 17. So that's it for number 3. Let's continue with number 4. We have 676. So is it divisible by 2? Yes, it is divisible by 2. Is it divisible by 3? So we have 6 plus 7 plus 6. 6 plus 7 plus 6. So we have 6 plus 6 is 12. 12 plus 7 is 19. So nah, it's not divisible by 3. Okay, it's not divisible by 3. How about if it is divisible by 4? So let's try to check. Let's try to we can check the both the last two digits, or we can check if the tenth digit is odd or even by rule 2. Since the tenth digit is odd rather, so since it's odd, it can only be 2 or 6. So since it's 6, okay, therefore 676 is divisible by 4. It's not divisible by 5 clearly. It's not also divisible by 6 because it's not divisible by 3 by our rule. Is it divisible by 7 though? Okay, multiply 6 by 2, so that's 12. Deduct that from 67, the remaining digits. This will give us, what, 55. And 55 is not a multiple of 7. Okay, so therefore, this number, 676, is not a multiple of 7, or not divisible by 7. Is it divisible by 8, by the way? So let's try. 6, let's put it here. 6, 7, 6 divided by 8. So what's the nearest number? 8. This is 64. And this is going to give us 3. And then 6. Okay, 36. How many 8s are there for 36? So that's going to give us 4. Okay, so that's going to give us 32. So 32, deduct 32 from 36, that's going to give us 4. So we have a remainder of 4. So yeah, therefore 676 is not divisible by 8. Okay, 676 is not divisible by 8. Next up, let's try if it is divisible by 9. So let's try. Notice that it is not divisible by 3. So since it's not divisible by 3, I think you can deduce that it's not also divisible by 9. It's also not divisible by 10 by for obvious reasons. Is it divisible by 11? So we have 6 minus 7 is minus 1. Minus 1 plus 6 is not going to be a multiple of 11. Is it divisible by 13 though? Let's try. 13 is 9 times the first digit. So 9 times 6 is 54, I believe. Minus that from the remaining numbers, 67. So what's the number? We have 1 and we have 3. So is 13 a multiple of 13? Yes, it is. So therefore, 676 is a multiple of 13. So let's check that one. And then let's try to check if it is also a multiple of 17. So 6 times 5 is 30. Subtract that from 67. What we have is 37. So nada, it's not a multiple of 17 because we have 17, the next number will be 34. So it's not going to be possible. Okay, so we're now here in the last number. So we have 13,192. First off, it's divisible by 2 because it ends with 2. Let's try if it is divisible by 3. So 1 plus 3 plus 1 plus 9 plus 2. So 1 plus 3 is 4 plus 1, 5 plus 9, 14 plus 2. That's going to give us 16. So 16 is not a multiple of 3. How about if it is a multiple of 4? Let's try to check the last two digits. Is it divisible? If you're well, the answer is yes, it is. But if you want to check, um, this is an odd number, 9. It if you want to check if it's divisible by 4, it should only be 2 or 6 if it's an odd number. So since it's 2, so therefore yes, it is divisible by 4. It is not divisible by 5. It is also not divisible by 6 by obvious reasons. By 3 here. Is it divisible by 7 though? So let's try. Twice the first digit, that's 4. Subtract that from the remaining number, 1319. Let's do that. What we have 1,315. And then let's continue the process. 5 times 2 is 10. And then subtract that from the remaining numbers, 131. What we have is 121. After that, let's try to check again if you want. So twice the 1 is 2. 2 minus 12 is going to give us 10. Okay, and 10 is not a multiple of 7. So therefore, implying that 13,192 is not a multiple of 7, no, given that long method. Okay. Anyways, how about if it is divisible by 8? So let's check the 192. Is it divisible by 8? 192. So divide this by 8. So we have 2, 16, 3 here, 32. And then we have 4. 4 times 8 is 32 itself. So that's going to give us a 0. So therefore, the remainder is 0, which means, yes, it is divisible by 8. So 30,182 is divisible by 8. Let's check. Is it divisible by 9 though? Since it is not divisible by 3, clearly it will not be divisible by 9. It is also not divisible by 10 by obvious reasons. Is it divisible by 11? So we have 1 minus 3 plus 1 minus 9 plus 2. So what you have is minus 2 plus 1 is minus 1 plus 9 is minus 10 plus 2 is minus 8. Okay, so it's going to be minus 8. Or if you want, we have minus 12 plus 4. Okay, still the same number, minus 8. So minus 8 is not a multiple of 11, so nada. It's not divisible by 11. Is it divisible by 13? So 13 times the last digit, rather, sorry, 9 times the last digit, so we have 18. That's 9 times 2. Subtract that from the remaining numbers, 1, 3, 1, 9. So clearly what we have is 1, 3, 0, 1. Multiply this by 9 and subtract that from the remaining numbers. So we have 130 minus 9. So what we have is 121. Again, continue the process. What we have is 12 minus 9. 12 minus 9 is 3. So therefore, 3 is not a multiple of 13. So no, 13,192 is not divisible by 13. Let's check 17 though. What we're going to do, similar with 13, is just multiply this by 5. 2 times 5 is 10. Subtract that from the remaining number, 1319. What we have then is 1309. Continue the process. I'm going to write the remaining number, 130 already. So 9 times 5 is going to give us 45. 130 minus 45 is going to give us what? Let's put 45 here. So 1 bar 1 bar 5. So what is this number? This is 0, 8, 5, correct? So that's going to give us 8, 5, because we have another bar here. Okay, so that's it, 85. So if you're not yet convinced, you can check that this 85 is actually 17 times 5. So 17 times 5, if you want to check, multiply them. This is going to give us 5. 7 times 5 is 35. Let's put 3 here and then 5. So therefore, this is going to give us, by rounding up, 85. So that's 85. So therefore, we can say that 13,192 is divisible by 17. Okay, divisible by 17. So that's a check. Okay, so that's it for this video. You can see all here that these numbers are divisible with. And yeah, for number 1, we have 1, 2, 3, 6 check marks for there. For number 2, we have 3. For number 3, we have 3. For number 4, we have 3. For number 5, we have also, not really 3, 4. We have 4 for number 5. Okay. Yeah, so that's it for this video. Thank you very much for watching. I hope you have answered some questions in your mind about the divisibility and the rules out of it. So yeah, thank you very much. Don't forget to like and subscribe, and I'll see you soon. Okay.